The last type of molecule that we're going to want to learn how to name are acids. Okay, so the definition of acid would be any molecule that forms either the H plus ion or the H3O plus hydronium ion in solution. Now I said or, and it turns out that actually they both are trying to say the same thing. When we take a little closer look at acid-base reactions in another unit, we'll discuss these two definitions. But either way you look at it, when any molecule that after it dissolves in water forms the H3O plus or H plus ion, we refer to it as an acid. One of the first things you probably learned about acids, of course, they have sour taste, and those would be, of course, your weak acids in fruits or vegetables. Citric acid is one of them. Your strong acids are able to dissolve many metals, such as zinc, iron, or magnesium. Typically are not able to dissolve the so-called noble metals, such as gold, silver, or platinum. Okay, as the name implies, since they have to form an H plus in solution, you typically will show what hydrogens dissolve or ionize in water by putting them first on the name. So here's HCl, H2SO4, and then this is acetic acid. And even though that there's 4 hydrogens in acetic acid molecule, one of those hydrogens will form an H plus ion in solution, so we write it out front. So anytime you see a molecule with an H first, it's a good indicator that it is an acid. Now we can break down acids into 2 categories. Either binary acids, where the hydrogen cation is comes from a molecule which is H and another element. Typically these are the halogens, very common acids that are binary acids. Or when the hydrogen is bonded to a polyatomic ion, which if you look back to the table of polyatomic ions, they have a lot of oxygen, so we call those oxyacids. Okay, when they bind to a oxyanion. Okay, so there's going to be 2 different sets of rules. One's for binary acids and one for oxyacids. Now, if we have a binary acid, the hydrogen is bonded to just one other element. We will first utilize the hydro prefix. We are going to change the base name of the nonmetal. We're going to add an ic to it. And then, just to be sure that we're talking about an acid, we are going to write the word acid at the end of the name. So here's an example. Let's name HCl, binary acid. Okay, what is the anion? We know that is chloride. So chlorine is your anion when it dissolves in solution. We're going to change that to ic, so that's going to be chloric. And we're going to add the hydro in front of it. So this would be hydrochloric. And for all acids, we are going to add acid at the end of the name. So HCl is known as hydrochloric acid, something you've probably heard of before. Okay, so for our oxyacids, there's going to be 2 types of names for those. Depending on the suffix of the polyatomic ion that the hydrogen is bonded to, it is going to determine its name. You can either have a polyatomic ion that ends with ate or ite, as we saw previously. If that polyatomic ion was an 8, we are going to change the ending name to ic. If it was ite, we are going to change the ending name to is. And of course, we're going to keep acid at the end. But this time, we do not have the hydro prefix. Okay, so let's name a couple of acids next. Here we have ones that the end of the names change slightly differently than the other ones, so we'll just point those out here. Okay, the anion is the oxyanion, the sulfate polyatomic ion, sulfate. Okay, we know that's -2, and that's why there's 2 hydrogens associated with that. Okay, it is an 8 ion, so the ending will be named with an ic. So we are going to change this to sulfuric. Okay, the sulfate sort of translates back to the sulfur name, and then we're going to throw on ic. But that's the only one that's going to do that. So sulfuric, and then of course we're going to need to add the acid. So sulfuric acid is the name of H2SO4. H2SO3 Well, we have to remember what that anion was. SO3, that's one less oxygen atom than the sulfate, so that was the sulfite, SO3 2 minus. And since it is ITE, it's going to change to IS. So instead of sulfuric, this is going to be sulfuris. And that's an O, sulfurous acid. Because, of course, we're going to throw in the acid at the end of the name. So sulfurous acid is H2SO3, sulfuric acid is H2SO4. And again, for the majority of these, we're going to look at the polyatomic ion, the oxyanion, figure out if it's an ATE or ITE polyatomic ion, and change the name accordingly. Okay, so let's take a few more examples. So what is the name of H2S? Well, that's just a binary acid. That's not an oxyanion. So that would be sulfide would be the element. So we're going to name that sulfic or sulfuric. And that is a binary, so we're going to need the hydro. Hydrosulfic acid, or sometimes referred to as hydrosulfuric acid. But again, hydro because it's binary. ClO3, what polyatomic ion was that? Well, that's our 8 polyatomic ion, chlorate. So this is chloric acid. Okay, HNO2, where's that? Well, HNO2 would be the nitrite ion, so this is going to be nitrous acid. And NO3 is, of course, the nitrate polyatomic, so this is nitric acid. And again, those polyatomic oxyanion acids do not need the hydro prefix. But all of them have acid at the end of their names.